In this video, I want to take a look at several things. Basically, it's going to be Chapter 13. With Chapter 13, what we're going to look at is, first of all, the distributive property. And basically, what that says, if you have a factor times a sum, then I will take that factor times each one of these pieces in that sum. So x times the sum of xy plus z is xy plus xz. Now let's take a look at what happens if I have a real example and see how this works. If I have 3 times 5 plus 2, well, 5 plus 2 is 7 and 3 times 7 is 21. But according to the distributive property, it should be 3 times 5 plus 3 times 2. Well, 3 times 5 is 15, 3 times 2 is 6, and you see that obviously it works. Now, quite truthfully, you can use that when you're multiplying something like 3 times 96, because it works with a difference also. If I know that 100 minus 4 is 96, I can distribute 3 times 100 minus 4, and that should be 3 times 100 minus 3 times 4. So you could do 3 times 96 in your head by saying that it's going to be 300 times 100 minus 4. And then I will distribute 3 times 100 and 3 times 4. You can do this in your head because you know it's 300 minus 12. And you should be able to do that in your head to get 288. Now that's a distributive property. You use that quite a bit. What we're going to look at, though, is the idea of factoring. And basically, we're going to work this backwards. We're going to say that I'm going to look for factors that are common between a polynomial. In this case, xy plus xz. Well, I can take this x and move it outside the parentheses and say it's x times y plus z, whatever is left over if I remove that x. If I have x squared plus 7x, you see that there is a common x. So I'll take that common x out of the equation and write it as x times x plus 7. If I distribute, I will get x squared and 7x. That's the concept. Now it doesn't make any difference what's common. In this case, I've got x plus 5 common. If I have x plus 5 common to both of these terms, I can take this x plus 5 out of the equation, out of the polynomial, and write it as x plus 5 times whatever is left over. In this case, x minus 2. X plus 5 times x minus 2. That's the concept. Now, in this case, there's nothing common, and I've got 4 terms. So what I would do is I would group 2 at a time. I'm going to group the first 2 and look what's common. Well, I've got looks like 2x common. So I'll take 2x out of this equation and end up with 2x times 3x minus 1. If I distribute just this piece right here, 2x times 3x will be 6x squared, and 2x times 1 would be the 2x. Now if I take a 7 out of this that's common, I'll have 7 times negative 3x plus 1. And again, if I distribute 7, I'll get 21. And 1 times 7 is 7. Well, that's close, but the signs are wrong. See, I've got positive 3x here, I've got negative 3x here. So the trick is to factor a negative 7 out. That makes it a positive 3x and a negative 1. And now I have a common factor of 3x minus 1 that I can pull out and write it as 3x minus 1 times 2x minus 7. Now I want you to keep this part in mind right here. The idea of factoring that negative sign out of that binomial, because I'm going to use it in the last example that I show you tonight. We're going to pull out a negative out of our factor, or out of our binomial, and I want you to pay particular close attention to that. Okay, Now, dealing with polynomials, there are certain special products that I want you to memorize. Okay, if I have the difference of two squares, here I've got x squared, here I've got y squared, and I know that that's going to break down into the sum and difference of their square roots, x plus y and x minus y. Z squared and 25 are both perfect squares. That will factor into z minus 5 times z plus 5, the sum and the difference of their square roots. 16x squared is a perfect square. Its square root is 4x. 7 is a perfect square. 49 is a perfect square. Its square root is 7. So it's going to factor into x plus 7 for x minus 7. That's the difference of two squares. It doesn't matter what those squares look like. In this case, I've got something squared, x plus 2 squared, and I've got z plus 5 squared. Well, it will be the square root of x plus 2 squared, which is x plus 2, plus z plus 5, and x plus 2 minus z plus 5. It's always going to be that same pattern, and that is the difference of squares. Now the next one is a little bit odd. You have to pay attention to some things. This is a trinomial square. And what I want you to do is look for perfect squares on the ends. In this case, x squared is a perfect square, 25 is a perfect square. The square roots are x and 5. Now the question that I have for you is, if I take 2 times x times 5, does 2 times x times 5, if I double the middle, it's 2 times those two right here, do I get this thing right here? Do I get the 10x? 2 times x times 5, in fact, is 10x. So the answer is yes. So that means that this trinomial factors into x plus 5 squared. The x plus 5 comes from those square roots. Next example. That's a perfect square. Its square root is 2x. That's a perfect square. Its square root is 7. Does 2 times 2x times 7 equal 28x? And the answer is yeah. So 2x plus 7 squared is the answer for that. Now, there are times whenever the signs might look a little different. What if I've got 12x, or x squared minus 12x plus 36? Suppose that I've got this one. That's a perfect square. Its square root is x. 36, the square root of 36, could be plus 6 or it could be minus 6. In this case, because I've got a minus here, I want to use a negative. I want to use the minus 6. Does 2 times x times negative 6 equal the negative 12? The answer is yes, it is. So, x minus 6 is the solution to this. So I take the square root of this one, the square root of this one, make sure you match up the signs, and you have the trinomial square. That pattern is going to be throughout. Pay attention to it. Now, the sum and difference of cubes, pretty straightforward. If I've got two cubes, a cubed and b cubed, the sum of those two, it's going to factor in a plus b. If I've got the difference of cubes, a cubed minus b cubed, it's going to factor into a minus b times something else. It's going to be always a trinomial. Now the only thing you have to remember is looking at those signs. First of all, that first sign will be different from this one. If it says plus, this one's going to be minus. If this says minus, this one's going to be plus. That's the only thing you have to worry about. The last term is always going to be positive. It is a squared, ab, and b squared. Pretty straightforward. So if I look at some examples, and the examples that I have here are 8 cubed, well, whatever it says there, x cubed minus 8. Well, the cube root of this one is x, and the cube root of this one is 2. So I know it's going to be x minus 2. This sign's going to match up with this sign. That sign pattern is this one will always be opposite of whatever it is. This one's always going to be plus. Now, what did I say it was? A squared. In this case, the first term is going to be x. It's going to be x squared. It's going to be the product of the two, 2x, and it's going to be that last term squared, 4. If I have z cubed minus 27, I know the cube roots are z and 3. This time I've got a plus, so this sign's going to be the opposite of it, and this sign's always positive. It is the first term squared. It is the product of the two terms. It is the last term squared. And that's all there is to sum or difference of cubes. Well, let's take a look at this one. 125 cubed, x cubed, the cube root is 5x. 64, the cube root is 4. Well, once again, look at the sign patterns. This is negative, so that lead is going to be positive. The last one will always be positive. The first one is going to be this first term squared, which is 25 x squared. It will be the product of those two, which is going to be 20x. Now, don't pay attention to this sign right here when you're multiplying. It looks like it's negative 4, looks like it's negative 20, but you got to look at the patterns here. If I've got the difference of cubes, this sign right here is always going to be positive, regardless of what this sign is. And that last one will be 16, 4 squared. And that's all there is to sum and difference. Now, those are the three types that I want you to memorize. You've got the difference of squares up here first of all, x squared plus y squared. You have a trinomial square, or you've got the sum and difference of the square of cubes. Okay? Now, what if they don't fit that pattern? Let's look at a general trinomial. Well, actually, it's pretty straightforward. What I want to look at is what is, if I have x squared plus 7x plus 10, what are factors of 10 that break into and add up to 7? What factors of 10 add up to 7? Well, the first factor that I can come up with is 1 times 10. But 1 times 10 turns out to be 11. That's not what I want. 2 times 5 is 10. And if I add 2 plus 5, I'll get 7. So I'm going to take these two numbers. That's what I want, is that I want to put in positive 2 here, positive 5 here. If I do this by FOIL, I will have the first term, the outer term is 5x, and the inner term is 2x. And you can see that that's going to add up to 7x, and the last term will be 10. Okay? So, now let's look at the next one. This one is x squared minus 20 minus x. Well, the problem is that this one's out of order. Okay? So I need to rewrite it descending powers of x. X squared, x to the first, x to the 0. Alright, now I want to look at what factors of negative 20 add up to negative 1. Well, if I take a look at factors of negative 20, it could be negative 1 and 20, and that adds up to 19. That doesn't work. Could be negative 2 and 10, which is 18. That doesn't work. Could be negative 4 and 5. That's close, but the sign's wrong. So if I have negative 5 and 4, there's my negative 1. That's what I want. I want a coefficient here of negative 1. That's what I've got right here. So I'm going to use these two factors, negative 5 and positive 4. X minus 5, x plus 4. Okay? Well, let's separate this. I don't want you to get too confused, because now I'm going to change some things up. I want you to be careful about this. Let's separate this. Because now my problem is, previously, all of these previous examples, the coefficient of x squared was always 1. It was 1 here, 1 here. All of the other ones were 1s. It's 1 here, 1 here. Now what happens if I don't have 1? If I got a 3x squared minus 16x plus 21. Well, what you do is you take the 3 and the 21 and multiply them. 3 times 21 is 63. Well, you could break this down if you want to, but I found it easier just to break down the 21. Leave it factored. And now group. See if I can group a couple of them. Well, let's take a look at the first one. The first group is going to be 3 and 21. If I group just this one and these two, that's 3 times 21. Well, that doesn't work. But what if I group these two and the 7? Then I'll have 9 times 7. Well, that's close. But remember, I've got negatives over here, right? I want to change that to negative 9 and negative 7. Negative 9 times negative 7 does equal positive 63. And if I add them together, I get negative 16. Okay? So now, I've got 4 factors. What do I do with the 4 factors? Well, I'm going to group the first 2 together and factor what's common. It looks like a 3 and an x common in those two. So I'm going to take 3x out of this thing. Out of here and out of here. And I'm going to write it as 3x times x minus 3. If I distribute that, 3x times x is 3x squared, and 3x times 3 is negative 9x. Now remember, I told you to pay attention to that factoring at negative. If I take a negative 7 out of here, there's a negative 7 in both of these, then I can have x minus 3, and now both of these are the same. And I can factor the x minus 3 out and have x minus 3 times 3x minus 7. Now I want you to notice that it doesn't make any difference. I could have written that as x minus 3 times 3x minus 7. It doesn't make any difference which order you put those in. Think about it. 5 times 6 is the same thing as 6 times 5. It doesn't make any difference which order you have, as long as you have both factors. Okay? Once again, had I taken the 3x squared minus 9x minus 7x plus 21, if I'd grouped those last two and taken a positive 7, I would have negative x and positive 3. And over here, when I took that 3x out, I have positive x and negative 3. And those don't match up. See, those two are different. I can't factor those out. They aren't the same thing. So use that little technique about taking a negative sign if the signs are switched on you for some reason. Take this example one more time. Sometimes it works, sometimes it doesn't. I have found, going back up to this example right here, the one where I have factors of 21, and I broke down the 21 instead of the 63. That seems to work better for me. You can do however you want to. If the 63 works better for you, by all means do that. Okay, let's look at one more example just to make sure that you've got this down. Let's look at 2x squared plus 8x plus 5y minus 15. Now if I group the first two and I take 2x out of each one, I'll have 2x times x plus 4. If I take a 5 out of this one, I'll have 5 times y minus 3. And what I want you to see is I don't have anything in common. Doesn't fit. Okay? This is not going to factor, so we're going to call this one prime. It doesn't factor. There's nothing common, and there's no way that I can manipulate that around and change it around to make it factor. There's nothing common because I've got a y stuck in here with these x's. It's simply not going to fly. You'll run into that on occasions, not often. Let's take 6x squared plus 19x plus 10. Okay? Now we're going to multiply 6 times 10. Now you could look at factors of 60, but you're going to break it down. So I take 6 times 10 and break each one of these down. 2 times 3 and 2 times 5. And now you just begin to group. Well, let's try this. Let's try 2 times 2 and 3 times 5. Well, 2 times 2 is 4. 3 times 5 is 15. If I add those two together, I will get 19. And that's exactly what I want. That's the idea of what I was saying about grouping these things around. You could just move things around. I could use 2 times 5 and 2 times 3. 10 and 6 doesn't quite get it. But here it is. Here are my numbers. 4 and 15. Now what I'm going to have to do is rewrite that center term, 6x squared, and it doesn't matter which one you use, plus 4x plus 15x plus 10. I could have just as easily written that as 6x squared plus 15x, 4x, and 10. It doesn't make a bit of difference. I've got a 2 and I've got an x common, so that leaves me 3x plus 2. Looks to me like I got a 5 common here, and it's going to leave me 3x plus 2. And by now you see there's the common factor. I could write that as 3x plus 2 times 2x plus 5. Now, oftentimes you'll see the idea of guessing, and the idea is here that I want to get the outer and the inner terms added up to be 19. And sometimes they'll say, well, just figure it out on your own. If you have some prime numbers, that works fine. If I take 4x cubed minus 2x squared minus 6x. I sure hope this works. Now the first thing I want you to know is I've got a 2 common here, here, here. I also have an x common. So I can factor, before I even start, I can write this as 2x times 2x squared minus 1 minus 3. Now normally I would tell you that you're going to multiply 2 times 3 to get negative 6 and go that route. But I want you to look at something. The only possible combinations I can have for that first term, because it's prime, is 2x and x. I can't have anything else. The only possible combinations I can have are 3 and 1, or 3 and 1. That's it. So I want my outer and inner terms to give me 1x. Okay? Now, I know those signs are going to be different. One of them is going to be positive and one's going to be negative. I don't know which one it's going to be. But if I look at 2 times 3 is 6, and x times 1, that's not going to work. But 2 times 1 is 2, and 1 times 3, and 2 minus 3 is 1. So I know that I have to have a negative 3 right here, and a positive 2 right here. I can do that by guesswork. Once again, let me eliminate this stuff so you can see what I'm saying. That should have been a 1, by the way. The outer term is going to be a positive 2x. The inner term is going to be a minus 3x. If I add those two together, I'll get negative 1. So that's the way you're going to factor that. It's a matter of speed and convenience. If you understand this, by all means, go ahead and use it. If you don't, factors of 6 that add up to negative 1 would be negative 3 and positive 2. There's a negative 3. There's the positive 2. You can go through that whole routine that I showed you up here, or if you can see the pattern that's evolving, you can use this method here. Okay, so that covers the general trinomials. We've got one more section in this chapter. Actually, it's chapter 14, rational expressions, and I'll do that on another time. That's all I have for this one, and so we'll call it a day.